In this video, we're going to be talking about transformations. So we can transform graphs of radical functions in the same way we transformed all of our previous functions that we've talked about. So first we can see a horizontal translation, where the graph shifts left or right, and that function notation is going to be f of x minus h. So for example, if I had the square root of x minus 2, that is shifting the graph 2 units right. When I have the square root of x plus 3, you can kind of think of that as being the square root of x minus negative 3. And so here my h is negative 3, so that means it's going 3 units left. We also see a vertical translation. That's when the graph shifts up or down. And so function notation for that is going to look like f of x plus k. So for example, here I have the square root of x plus 2. That means this is going 2 units up. And then below that, square root of x minus 7. That minus 7 means that's going 7 units down. And then we have reflection, and that's when the graph flips over the x or y axis. And that function notation for that first one is f of negative x. So for example, the square root of negative x. And that would mean there's a reflection in the y-axis. When the function notation is negative f of x, so for example, negative square root of x, that reflection is in the x-axis. And then we have horizontal stretch or shrink, and that's when the graph stretches away from or shrinks toward the y-axis. And that function notation is going to look like f of a times x. So for example, when I have g of x is equal to the square root of 3x, this is going to be a shrink by a factor of 1/3. So remember, with horizontal, we really take the flip of what we see in there. And then another example is g of x is equal to the square root of 1/2 x. Remember, we flip what we see in there, so this is really 2. So that means this is going to be a stretch by a factor of 2. And then we have vertical stretch or shrink, and that is when the graph stretches away from or shrinks toward the x-axis. And that function notation looks like a times f of x. So for example, I have 8 times the square root of x, so that is going to be a stretch by a factor of 8. Or if I have g of x is equal to 2/3 times square root of x, that would be a shrink by a factor of 2/3. So kind of reviewing that, horizontal and vertical are kind of opposite. For horizontal, if a is greater than 1, then it's a shrink, since you're really going to be taking the reciprocal of it. So it's going to be a shrink by a factor of 1/a. And if a is between 0 and 1, then it's going to be a stretch by 1/a. And then it's complete opposite of that for vertical. If a is greater than 1, then it's a stretch by a. And if a is between 0 and 1, then it's a shrink by a.